So welcome to this session on data normalization and allocations, which is a critical topic for finance and planning Essbase implementations. Allocations come up in almost every production Essbase project, so it's worth covering this session. So in previous videos, we built a foundation like calculation order, scripting with fix and if, intelligent calculation, topics. So allocations use all of this concept together. So data normalization means loading data at summary level and then distributing it down to the detailed members. For example, your finance team provides a total corporate overhead figure at a company level. So as you can see, this is the example. So at company level, we have a corporate value, right? So we have a corporate value at a company level, but this needs to be allocated to each department or each entity. So you load the total to the parent, then use an allocation script to push it down proportionally. So ratio allocation is the most common approach. So we use driver data like headcount, square footage, revenue, or carpet area, or any other ratios which as per the business requirement, which determines each member's share. For example, if department A has 40% of total headcount, it receives 40% of allocated cost. So in Essbase, you calculate the ratio first, then multiply the source value by that ratio for each target member. So count-based allocation is very simple. So count-based allocation, if we see, it is an equal split across all target members, so no driver needed. So if a parent has 4 members and parent value has around $100, then it will allocate $25 for each members. So there is no ratio required, it just divides by number of members and allocates equally. So this is count based allocation. Then we have a multi-level allocation which cascades through hierarchy levels. For example, allocate corporate cost to divisions, then from divisions to departments, and from departments to cost centers. So there is a multi-level allocation. So each level uses its own driver and logic. Build these as a separate script step so that you can test and debug each level of allocation independently. Let's take an example. So we have a corporate. So CFO provides a total market budget of $5 million, right, at a corporate level. Then requirement is you need to allocate to a region based on the revenue share. So think that this is a region. These are the number of regions, and the $5 million need to get allocated to these regions or department based on the revenue ratio or the revenue percentage or the revenue share. Then from region to the product line based on the unit volume. Then from department, it has to go to projects as shown here. From region to projects based on the unit count or the unit volume. So what is the step 1? Let's I'll take you through a real-time example. So as you can see, we have loaded $5 million, right, at a all region level. So this is at the parent level. So we have $5 million and there are 4 regions and its respective revenue value, which is 2, 3, 2 and 4, that is around $11 million. So how exactly this value should get allocated? Let's see. It's based on the revenue percentage. So how will you find out the revenue percentage? That is each region revenue. Let me do it here. Each region revenue divided by the total revenue. So this is the percentage. Let me fix on the total so that it won't vary if I drag to other cells, right? And at last it comes to 100%. Let me change this to a percentage so it will be clear. Yeah, so East region should get 18% of 5 million, West region should get 27% of 5 million, and so on. So what should be the value? It is 5 million. Let me fix this into the percentage of each region. And if I drag and drop for each region, this should be the ratio or the value to get allocated. So overall we get $5 million. Let me take you through a business rule. So in the previous video, as explained how to write a business rule. So first is the business rule and which application it applies to, and to which module, and who's the author, and when it was created, modified, and the version name, and what is the purpose. Just a one-liner should be sufficient. And what are the allocation drivers we are using. So if these details are very clear in the business rules, it will become very easy to troubleshoot this business rule in case we find out any issues. And these are all the fixed members which has been fixed inside the statement, because all these members will never change. So all these members are declared under fixed statement. And if we see the formula is very simple. All region value OFS direct input, that is this combination, all region value OFS direct input divided by into each region's revenue, because I have taken total region, so it will for loop for each and every region. So each region revenue value divided by the total region. That is what we have done here, right? Each region revenue divided by total value, we get a ratio. So this portion, the second portion, we get a ratio or the percentage, and we are multiplying with $5 million, that is this value. So once this script runs, we get the allocated value. So let me execute this script. It should not take much time because we are using a less number of members. Yeah, so the script is completed. Let me refresh the sheet. So if you see, we get same data which we calculated earlier manually. So this is how the allocation worked. Now we are done with first level of allocation. Now this allocation, whatever the allocated value, needs to get allocated to the product level. It's the same combination which we saw in the previous sheet. So this value, so region should go to the region specific products, right? And products should get the value should get allocated to the products based on the unit volume. It is same concept, that is the product unit volume divided by total product volume. So let me fix this as well. And if I drag and drop and change it to the percentage, this is wrong because it has to go to its respective total product, right? And the value is calculated as 909. So it's only East region, right? So we need to take only the East region value into the percentage. So if we see here, 9090901 is what is present in the East region. So total also we got the same value. Let me validate that. So East region value minus total coal product. So it is 0. So this is what the value is we expect once the allocation runs. Hope the concept is clear. So let me take you through that allocation as well. So here you can observe that I have two allocation business rules. So we could have written in the same business rule. So in order to keep it tidy and more user friendly, so developers can go through its respective allocation logic and troubleshoot it, which will be more easy. And this also follows the same syntax. So first is regarding the business rule, why it is been written and what is a business logic and business requirement, followed by the core logic. So fixed statement, fixing all the members which doesn't change. And if we see an allocation process, it is OFS calculated of each of all the regions. So we have taken a total region. So total regions cost of sales, OFS other cost of sales is what is required. OFS other cost of sales for all the regions at no coal product. So no coal product and OFS calculated. So this combination we are taking into unit volume of OFS direct input. So unit volume of all the products. So first it comes to a thermal coal. It gets this value 20 divided by unit volume OFS direct total coal product, that is nothing but 100. So 20 divided by 100, that is 20%. So let me execute this script. The script is over. Let's see the allocated value. I'll just refresh the sheet. So we got the value what is been expected, and the manual calculation also has the same value. So this is what is multi-level allocation is based on the driver data. So let's recap. So what we did, step 1, we loaded $5 million to a corporate parent. Step 2, we calculated each region's revenue percentage. Step 3, fix to each region and allocate its share. Step 4, within each region, we calculated the product line volume ratio and allocate again. So this is a 2-level allocation. So use separate fixed blocks for each level and document the driver logic clearly. So what does a common mistake developers do? That is allocating to members that do not exist yet. Scenarios, if your outline changes, that is new market or new product members are added, our allocation script may error out or produce a wrong result. So always validate that target members exist before running the allocations. Another pitfall is circular allocation, where A allocates to B and B allocates back to A. This creates an infinite loop or incorrect values. So you need to design your allocation flow as a directed graph, that is always top down or bottom up, never bidirectional. The small suggestion is create a dedicated drivers scenario in your outline to store the allocation ratio separately from actual data. So this makes your allocations transparent and auditable. Finance teams can review and adjust drivers without touching the calculation script. So that means at first time we can count or we can produce the driver data as a ratio. Finance team can review that driver data or the ratio and they can make the manual adjustment and then run the allocation process. Right? So this concludes our Essbase calculation database series. So you know how to complete the toolkit, right? So dimension theory, calculation order, scripting with fix and if, intelligent calculation, development process, and allocations. So build your script methodically, test thoroughly, and document everything. Thanks for watching and good luck with your EPBCS implementations. Thank you.